Welcome, everybody, to Heavy Strategies, the show where unanswered questions are a whole lot more interesting than unquestioned answers. Today, we have a special guest, David Stengel, who is going to be talking to us about cognitive load of platforms in your organization. And oh, by the way, he's an IT guy, not a psychiatrist, but still, this concept of cognitive load of platforms is quite interesting. David, thank you.
Um, this is my first podcast, so please excuse me if I don't get the the ins and outs. In the IT industry, we've been talking about platforms for a long time in the context of the amount of effort that they remove from people using them.
So when you say platforms, you're talking about things like VMware for virtualization.
I have a nice, simple working definition of platforms. A platform is a place or a system that allows you to build things and gives it a home. And the other thing that a platform does is it either takes work away from you or at least abstracts work, capture the work that you might need to do, or just make it easier to do the things you need to do. So operating systems fit into this. Salesforce fits into this, VMware, but I'm mostly focused on technical platforms like the VMwares and Kubernetes and Cloud Foundry and serverless and things like that. And I was, recently doing some research and finding other people that have said congruent things, I'd say, with cognitive load is that everyone's focused on the developer experience and how do we make it as easy as possible for them to get their job done. If you make their job really easy, you're making someone else's job really hard because, the cognitive load is a thing across the entire organization. So if you trivialize things for someone, you're probably making them really complex for someone else. But I think we don't necessarily think through what are the impacts of cognitive load organization-wide, as opposed to just focusing on developer experience. There's some additional stuff beyond just cognitive load where there's something called mental workload, where there's been a bit of research in that, and NASA has focused on that because cognitive load theory is very focused on learning and specifically what happens in like a classroom environment, learning environment. How do you get people to absorb material? And it kind of crosses over a bit into task-oriented things that are not quite learning, but mental workload kind of embraces the full range of challenges with getting things done.
We create platforms in IT, and the purpose of the platforms is to reduce the cognitive burden, that is how much we have to learn to achieve an outcome. The alternative would be that you would be handcrafting some artisanal virtualization platform or some container platform. That's not realistically practical. So humans necessarily start to create platforms, say, like around containers. Docker was an early one, subsequently replaced by Kubernetes, subsequently replaced by serverless, which is even abstracting even further away. And you're saying, or at least hinting at, the fact that that is a psychological factor, and it's to do, at least in part, with cognitive load and the human ability to only understand so much.
Exactly. It's understand and juggle. And you brought up a very good point about learning these things, because it's one thing to learn about a platform and how to work with it, and then it's another thing to actually use the platform.
Right. So this is coming down to the idea behind the metaphor I use here is cars. Just because you drive a car doesn't mean you're a mechanic.
Exactly. Right. And just because you write Java code doesn't mean you're a kernel developer. And that's the thing that you brought up, the progression from, VMware on, you can go backwards too. Platforms, operating systems are platforms. And, people don't care about processes and memory management and block storage anymore. That's all been moved down the stack. It's there. It's abstracted more and more layers down as we go on. These layers of abstraction keep getting built over because the things that we're trying to do are higher and higher level. And we're trying, the cognitive load kind of shifts. It's not like it's a consistent fixed thing. Things we're able to attempt because of the work being taken away from us, the undifferentiated heavy lifting, right? As more of that gets taken away, we get to think about other things. And those other things tend to be sometimes more and more challenging. It's almost like this treadmill, right? The platforms need to get better because the things that we're attempting as they get better are more complex. And
I think there's a few things going on there. Once you move, we start off understanding things like storage and as blocks, and then networks as packets, or in the old days it was frames, and now it's packets, and now it's some imaginary...
frames, come on.
Over time, we build complexity on top of those. I think what you're hinting at here is that the cognitive load, and cognitive load is a well-known psychology thing, right? There's only so much cognitive capability that a human has. They can only understand so many things. Some people have better skills or talents or willingness to learn. There's a whole discussion there about how do you build cognitive capabilities and all that sort of stuff. But I don't think we're going to talk about that today. As the stack gets more complex, it's not possible for somebody, say a developer, to be conscious of what blocks mean in terms of writing data to a database. It just doesn't make sense. There's no capability. Their cognitive functions are addressing the business problem and the coding function. They just want to write to a database, and they don't want to know that it's sitting in a VM or it's on Oracle or it's in the cloud.
And they don't want to actively. So I think, and that's the difference between the learning and the doing.
Yeah.
Is that it's possible for people to know these things. If they get tied up in the doing of things, then it's a different problems. I love knowing, back when I started in the mid-90s, it was really popular to interview sysadmins about the basics of processes and file systems and inodes. And I still ask those questions when I find an old salt, that should know these things. I ask them, what is an inode, right? And, it's fun for me. But at the same time, I don't necessarily want to have to think about that when I'm getting certain things done. And that's, I think, the important thing about the mental workload idea is that it's really about getting tasks done as opposed to learning and understanding things.
And I want to weigh in on that and highlight that a little bit, because I think it's a key distinction. It's not that you don't have to know something, it's that you are not focusing on it actively when you're doing your job, because I think it's actually both possible and important to learn basics and then build up from there. But when you're working, if you're spending any time thinking about it, it should be literally lying dormant in your consciousness and popping up only if and only if, in the very, very rare circumstance, it actually matters, which most of the time it won't, because everything's been abstracted. But I'd also like to shift the conversation slightly, because there's an element to cognitive load. Remember, we're talking about organizations, not just individual developers. And the element that I found fascinating, David, when you mentioned it, was this idea that a platform is something you develop to. So, you can throw Salesforce in there, you can throw Notion in there, but the idea is there's a collective amount of time and energy and wisdom to thinking about how to do stuff, and, in platforms like Notion or Salesforce or whatever it is you're using. And to me, that immediately signaled that there's an optimization problem out there that says, for a given organization with a given measure of complexity, whatever your measure of complexity is, there's an optimal number of platforms that you want to be really focused on. And there's no single answer. It's not 1 or 17.
Exactly. It's very context specific.
And what I see when we walk into an organization, and one of the first things we do as part of a cloud migration strategy is to say, hey, how many applications do you have? And I'm thinking that another key question should be, how many of them are platforms? Because I don't really care about the things that are running in the back. Time, let it go run. Let it go tell me what time it is. Nobody ever develops to time. Well, that's not quite true. Anyway, you know what I mean? You know what I mean, right? Applications where you're investing significant amount of time and energy. And it would be interesting if we could arrive at a metric that says, basically, of your applications, no more than 10% and optimally about 5% are actually platforms or whatever.
I like that take. The way I've been thinking about it is a little bit more focused on kind of the larger supportive platforms at first, and thinking about it in terms of the appropriateness of the platform also for the organizations. The other thing you usually do when you do a cloud migration is you do a DevOps assessment, a maturity assessment, and you figure out where the organization's capabilities are with respect to what you're trying to get them to do in the cloud. Do they, are they still writing big monoliths and compiling C code, and you're trying to get them into serverless? That's probably too big of a jump. The other side of the cognitive load and platforms is you want to find platforms that are appropriate for the organization itself. We talked about attempting complex problems. If you have a system that is able to solve complex problems, there's probably a buildup you need to get to be able to even work on those complex problems, and therefore need a system that's probably, even though it's abstracting stuff away from you, it's possibly abstracting so much that you might not be able to understand it. And this is something we faced when we got to microservices, right? We wanted to get people to microservices, but we had to get them to understand immutable infrastructure. Infrastructure is code, directory and dynamic systems can, all of these concepts that would allow them to do what we thought was important, which is the microservices part. But it ended up being a big ball of complexity that is still there. Like, it's not as if that's all completely solved with Kubernetes and containers and service meshes and all of that. There's still a lot of that complexity kind of exposed to the users of the system because it's somewhat abstracted, but it's not completely.
Just because you build a platform doesn't mean the problem went away. You've managed the complexity for certain consumption of those services, right? So VMware made it easier to run virtualization by putting the storage and the networking and the compute into less complex configurations. In fact, computing and storage and all of that, the hardware infrastructure by and large, got a lot simpler when VMware came along because infinite variety was not permitted. And when you move into microservices, again, infinite variety of choices is not permitted. If your software can only run inside a container and can only use immutable infrastructure, you've actually got less choices than you had before. You don't have all this capability to run an infinite vertical scale. You have to think about scaling out at the start. That's a problem, but it's not cognitively more complex than running it on a single server once you just put a load balancer in front of it, because your choices are restricted, your infrastructure has to be immutable, and none of the state can be temporary, it has to be permanently state driven. And so all of a sudden you're forced into stuff where the cognitive load is less, in my opinion.
It is, depending on what is exposed to the developer, right? Because, for instance, it's no more complex in a single server with a load balancer. In a sense, in the old-fashioned world, the platform was really the IT group, and the IT group took care of a lot of that stuff for the developer, right? So they asked the developer, can this be load balanced? Okay, we'll load balance it for you. And there was a lot of various amounts of integration required by the developer, but it was a shared thing. Now we basically ask the developer, as part of DevOps, to take care of their stuff end to end. Depending on the organization, there may or may not be that level of support, depending on how sophisticated the platform is that they're working with. So some people might give them, here's a Helm chart, or here's a sample Helm chart, and you figure it out from there. And other organizations might say, okay, copy this framework archetype project and drop your code in here, and we'll take it from there. That comes down to what we're offering the developer in terms of access to the abstract, like who gets to work with the abstractions or who has to.
Yeah. One of the interesting things about load balancing is that the eighth, not most profitable, but the thing that customers spend the most money on, number 8 is elastic load balancing in AWS. The service that AWS provides is such an expensive service to consume that you could make the case that it's not fit for consumption. But because the developers don't care, they don't see the costs 9 times out of 10, there's not an instant feedback loop on that. Whereas in before, when it was done on some sort of hardware load balancer, the cost was trivial. The cost of a load balancer was never number 8 in the infrastructure cost. It was just like you bought it once every 5 to 10 years. And
it was a rounding error.
It was a rounding error in the overall cost. And yet now Amazon's managed to convince customers that elastic load balancing is worth 5 to 10% of their overall bill. It's amazing.
Well, I want to sort of grab onto what you just said, Greg, and sort of carry this a little bit further. I think the concept of cognitive load of platforms is really interesting, and anyone who's listening is probably going, oh, wow, yeah, I never thought of it that way. But at a practical level, what do you do with it? Our audience is architects, chief technology officers, and if they're saying, okay, now I need to think about this, I sort of had an intuitive sense that I don't want to have too many tools running around my environment, but what do I do with the knowledge that there's such a thing as cognitive load, that it affects organizations as well as individuals, and that it applies to platforms? Those are 3 novel things. What do you do? Like, what are things?
I just want to jump in because I've often thought of cognitive load when I'm building teams and managing project teams, and the project teams that are failing most often don't have the cognitive capabilities. That is, they can't see the business issue, they can't see the how the technology brings benefit. They can't comprehend the vision of what this new technology or this upgrade will do, and they really struggle. And the project teams that generally are more successful where the executives or the senior architects are people who say, yes, we have a clear vision, we understand what's going on, I understand this technology, I understand what this is, and it can go ahead. Is that a reasonable interpretation, David?
So that, to me, seems a lot like a team topologies approach. They bring in cognitive load as far as once you have a well-functioning team, then either they know what they're doing or not, which is sort of what you're getting into. The context isn't necessarily set right for them, or they're overloaded with work. And their focus is on like right-sizing the teams or right-sizing the work on the teams, because they kind of take maybe the somewhat naive view.
I wasn't just alluding to sizing of teams. You can put 10 incapable people on a team and that you'll still end up with incapability. What I'm more using cognitive load for is to say, go back to the executives and say, these people don't have the necessary skills or the necessarily emotional intelligence or the necessary will to excel.
I don't. So I'm not using cognitive load as a discriminator. Sort of. If you take IQ tests, tests were invented in France to evaluate students for what they needed to learn, where their gaps were. And it got brought over to the US as a filtering function for how smart people are. And so the way I look at cognitive load, it is a measure of how well the organization is functioning. Through that, potentially how well the platform that they've chosen is serving them. So to be more specific about what Jana was asking is, if you have some feel that the cognitive load distribution isn't good or something like that, even without thinking about it directly as cognitive load, you can go out and evaluate how good your platform is. And so the way that people usually rate platforms these days is by ilities. You have the scalability, the securability, there's this like huge list of ilities, they now call them. What I think is that in addition to rating your platform in terms of objective technical aspects, you also need to take an activities view. What does it take to actually work within the platform? So what does it take to do a deployment? Now, that might all fall under the usability of the platform, but I think that even a subjective view of that, like asking people, what does it take for you to get this done on all these different activities that are part of your job, is valuable. And this is the kind of work that you would do in just a sort of standard product management fashion. And so if you're running a platform or a technology organization in general, one of the best things you can do is treat it like a business with customers who have options and needing to understand your customer and what their needs are. And so if you were to just take away the fact that you need to understand your customers and what their experience is, you don't necessarily need to go through a specific cognitive load exercise. You can just go out and say, what's your day-to-day experience like? Where are your pain points? Like, this is the new focus of platforms, is a lot of treat it like a business with customers. I'm thinking of getting more specific and having, like, for a given context, a role within an organization or things like that, maybe have a list of standardized activities that they need to do, and then have like some way of assessing what their mental workload is for performing those activities. And kind of mapping that back and almost coming up with something a little bit like one of the, a spider graph, the platform.
Right, where you're focusing.
But more focused on activities. What a lot of places tend to do is they like look at that as a maturity model. They say, oh, you're not very good at CI/CD. Right. What I want to say is CI/CD is hard, and maybe
that's where you're spending most of your time. Right.
Yeah.
And maybe if you could focus on these three axes and just drop these other two where you're bubbling along at a 2.5 out of 5 or whatever, you will get more done. That leads me to my next question, which is, what role do you see AI playing in all of this? And before you answer, let me preface it by, when you said, okay, it would be super useful to know where you're spending all your time, and then whether or not that time is, that investment of time is merited, can you reduce the number of platforms you're focused on? I thought, wow, A, that's fascinating. B, I don't want someone sitting there with a stopwatch and clicking on and off. C, that sounds like a perfect thing that AI could probably do, is kind of sit there and go, you're spending all your time over here, and actually that's important, so you should spend even more time over there, so let's see if we can carve out these other pieces or something. That was my immediate thought when you started describing, the spider diagram.
It's potentially a data reduction problem, and it's something that's been a battle within organizations just for years in terms of DevOps. It's like, how do you get to the point of knowing whether or not you're performing or your performance is changing even, right? So
And
there's a lot of
it just seems like
signals.
automating at least the record tracking and probably the focus. I mean, it seems like it's a fairly straightforward app to create that says,
Yeah,
oh,
and it seems straightforward, but the signals are difficult to collect.
but
So,
that's where AI starts to look really
well, it's
interesting
starting to
across
look
a
good
large.
now. It's starting to
Yeah,
get
right.
much better now.
Yeah,
Like
20
three,
years ago,
4
you
years
couldn't do
ago,
this. Yeah,
the
even
signals were trapped inside of
no.
systems that were required much more explicit development, basically,
Right.
to pull out the numbers. Whereas now you could probably just point, at all of your Git commits and say,
Exactly.
correlate these with tickets, and the subjective experience of the people in the organization is still important to figure out, because a data-driven optimization based on behaviors is important, like observing behaviors and seeing what people do is important, but it's also important to find out, this very human-centric approach, like, how do you feel about what you're doing? Maybe somebody thinks something is hard, and you need to figure out why they think it's hard. Is it because it's hard? Is it because of sometimes it's just documentation. Sometimes it's people just don't know that there's a hard way and an easy way, right?
Why do people think things are hard? I mean, I was working on a project recently, and I had the worst case of writer's block / procrastination I've ever had professionally. And I'm like, why? And I realized that it was hard, not because it was intellectually challenging, but because I had to operate within a certain set of constraints that weren't defined by me, that understood by me. I had no idea of the underpinnings that we were trying to meet. Okay, I don't really understand what's going on with IO here and queuing and everything that's happening in the system. I don't get it. So it's really hard to determine whether what I've done actually is fit for purpose, and therefore I'm going to stick my head under my desk and stay there for a while.
And that comes back to the experience shows or experience tells.
Yeah, right.
But
exactly,
what also comes from experience is you're building up your cognitive capability. If you've tackled multiple problems that you can't solve. So I have a little mantra that I run around with is never let a solution get in the way of a problem. Just because there's a problem and you don't know how to fix it doesn't mean you should get in the way of solving the problem. Right?
Well, and I actually like that, Greg, for another reason, because there may be a solution that worked great with the previous constraints. So you're walking around going, I know how to solve this problem. And this is particularly dangerous for people like us. I know how to solve this problem because it works great with the constraints. And somebody goes, yeah, but those constraints don't exist anymore. So maybe a totally different solution.
You think you've come in so many times, you and I have worked with people who would have said, oh, I know how to fix this. I'll use this solution that I use somewhere else, without any awareness that a better technology has arrived or a better platform has emerged.
Yeah, and that's the trade-off between experience and innovation. We fight that constantly. I mean, the reverse is true, right? How many engineers imagine constraints and then spend time working on those rather than what they really should be, right?
Well,
I'm going to invent new platforms. I'm going to build a system for generating complex forms. You do one form every 2 years. Like, you don't need to do that, right?
You immediately caused me to flash to a client who is rejiggering the entire team in the wake of the departure of somebody who is essentially one of those people that we all know exists. The architect who solves every problem, who's super brilliant, but solves every problem by creating a solution that only works in his brain. It works very, very well in his brain, but everybody else suddenly has to drop everything they've already learned, get into that guy's brain, figure out how his new solution works, and he's off and running to the next solution. And when you think about that, it's sort of it's a good way to look at your team to say, okay, how good are they at repurposing existing scenarios so that you're minimizing the cognitive load for everybody else, versus I'm minimizing my own cognitive load because I've created a solution that works only for me, so I don't have to worry about learning.
Yeah, exactly. There's not a very even distribution there, right? Like, the architect has a role, and so do the other people in the organization. And, in that one, it's unbalanced, right? It's one of those, the cognitive load is all being thrown into someone who, you like you said, it's in some ways he's taking it on because he can do it for other people, but at the same time he's making it harder and easier. And the hard part comes when he leaves and nobody else understands how to do what needs to be done because that was never spread around. There's another interesting concept I ran across when I was kind of researching into this. It's called psychological capital. So these four elements that make up psychological capital, and I'm not necessarily remembering them all, but one of the most important was personal efficacy. So how effective do you feel you are? And someone's belief in that, like their ability to get things done, is a big part of their overall psychological capital. And when you think about it, your ability to feel like you can get things done is partly up to you, partly up to your environment. So if team doesn't have the understanding of what needs to be done, then it's difficult for them to feel like they're going to be effective in getting something done.
Yeah.
It's another form of cognitive load to work in uncertain circumstances, right?
So, David, I just wanted to give away one of my, what people call secrets of success. My one way that I've always approached design challenges, like I would come in as a consultant and sit down in front of these people and they would look at me and go like, well, you're the person who's going to have to come up with a solution. They'd be delegating their cognitive load to me. And of course, I'm coming in completely cold, no idea of what's going on. So I used to use what I called, in my head, a design principle called invariant design. And that was to literally locate the points in what the customers had that was invariant, that could not be changed. When you go into a consulting gig or you go face-to-face, what I'm probing for the first period of the engagement is not only what the customer wants, but the things that cannot be changed. Oh, Mr. Customer, you're using Microsoft SQL database. Can that be changed? Can we go and buy Postgres or SQL, MySQL? Is that allowed? And if the answer is no, well, hey, you've just reduced your cognitive load by a lot because you now know. And if you go in and the customer says, oh, no, I want a solution, but it only has to come from this brand, you might go, not quite invariant. If I can find a proper solution, I can change that. But for now, I'm just going to write down must come from this portfolio because it reduces my cognitive load in reaching a solution. I think, and I didn't particularly realize it as a cognitive thing. I never thought about it as cognitive load, but is that viable from your perspective?
Absolutely. I mean, I'm starting out applying cognitive load specifically to platforms because it's an entry point that I have a lot of experience with. Mm-hmm. But talking with other people, we're talking about specifically like the underpinnings of technology businesses. Mm-hmm. But when you think about application architecture, if you make application architecture so complex and like especially older systems that even the architects have trouble figuring out how to get new features to work, right? Mm-hmm. And not even thinking about the databases, just all the systems interactions that they have to deal with.
A lot of times these days, the developers actually make decisions before the architects, and the architects get it after it comes out of the poop chute.
Yes, and I think that's also because the idea of self-actualization has been taking hold in the industry in terms of moving, again, this personal psychological capital, which not many people think about, but making people more and more capable, right? And so you want to make developers more capable, but we haven't moved the architects into a model where they're essentially supporting teams. They're usually still stuck in the, I'm going to figure it out for you and give you the work. And so teams want to run ahead of that bottleneck, and they end up doing that. And then, you end up with that bad cycle of architect to team that, we did it, we're waiting for you, but so is like 10 other teams. You can only process one or two at a time. I think the industry shift is leading to a lot of kind of grinding. And again, it's another form of distraction, right? Because that's a lot of what, cognitive load is somewhat about, right? It's distraction. Like you're trying to work on a problem. Part of the issue with getting it done is either you know it or you don't, but also what are the extraneous things that are taking you away from the problem? Those are the three different types of cognitive load. There's the problem you're working on, the intrinsic. There's the implicit, which is the knowledge you need to work on the problem. And then there's the extraneous. And to go back to what you said about cars, my my best example of how cognitive load, those three things come into play, is driving a car. When you first start driving, the load of just operating the car is so much that you cannot do anything but drive the car. You can't even handle the task of navigating somewhere, right?
Yeah.
So that by itself is a challenge. When you get good at driving a car, it becomes easier and easier.
You get to your destination and you wonder, how did I get here? Oh well,
Right.
Exactly.
Not that
but you still have the extreme. So I'm going to drive, and I'm going to drive to a destination. So I need to know how to drive, and my task is to drive to a place, right? But then there's traffic, or there's a emergency, there's a crash, like these extraneous things come up, and they start like taking me away from the knowledge I have going to being applied to the task. Suddenly I have all this other stuff happening. Distraction in a way. Now, it's a distraction for a developer to know about processes and memory management and yada, yada, yada in today's world, right? In
Yeah, it's
20
like
years
knowing how to
ago,
work a stick shift.
yeah, exactly. Like you can't even buy a stick shift from Audi anymore.
Kidding, really?
No, they only sell electronic transmissions now. They're manuals, but they only do paddle shift because that's a next layer.
Oh, come
that's a next
on.
level.
Don't be an
thing.
old fuddy-duddy and pretend that changing gears was a worthwhile life experience.
No, it really wasn't. It was right up there with
with
multiplying two numbers together in assembly language, but nonetheless,
press the clutch. Make sure declutch.
Shush, guys.
Come on.
Off track.
I think we can kind of call it a bit of a wrap. Greg, do you want to kind of?
Okay, we've just been hitting this discussion and we've sort of been freeballing on this one. We don't know if we've actually gotten into anything, but it's a bit of a different approach to having Jonah and I bang on at each other and butt heads on a given topic. And so thanks very much for David Stengel for coming in today and throwing something into the mix about the concepts of cognitive load in the capabilities of your IT architecture. If you've heard something that you like and you want to hear more from it, just hit us up at packetpushers.net/FU. Send us your follow-up. Tell us what you thought. And if you want to hear more like this, let us know what it is that you want to hear, because somebody did write into us and say, I'd like to hear more about various things, and this show extended out from that. And also, if you are listening and you think you've got something to say, get in contact with us. We'll have a chat to you and see if you have what it takes to be on the Heavy Strategy Show. As always, you can find many more podcasts like this over on the Packet Pushers Network. Go and check it out at packetpushers.net. There's 7 more channels of technology content there for you to listen to. And don't forget to head over to community.nemertes.com. That's NEMERTES.com. That community there, just sign up and Jonah will let you in and you can participate in the Nemertes community that Jonah's got going, and you can talk about esoteric operational and management issues with a bunch of other weirdly strange operational and technology professionals. As always, thank you so much for listening. We'll see you in a couple of weeks.